Hi friends, welcome to my YouTube channel. In this video, we will discuss about why we have moved from Docker to Kubernetes, what is the difference between container and pod, and what is the difference between pod and deployment in Kubernetes. Let's start with container. Container are standardized executable component that combine application source code with operating system libraries. It is light in weight because it has some dependent system libraries along with the application source code. It will not be having the whole operating system. It will share this operating system libraries from the host operating system. So containers can be a database, web server, or any backend services. Like suppose in this pictorial diagram you can see a container, right? So this container, if you want to create it by using a docker command, we will run like docker run -d or -t for interactive mode or a detached mode, followed by image name and -v for a volume, -v network for setting up the network in docker, -p for port. So everything, these commands will be in the command line. So this kind of approach is called imperative approach, and Docker does not support enterprise standard. These all are like command line commands, and this is not a declarative approach. So this is not supporting the enterprise standardization. Also Docker, with the help of Docker, the limitation is we cannot scale up. Auto scaling is not there, or auto healing, that concept is not there. And suppose C1 container is launched on one host and there is another container called C2 container that is launched on the another host. So the communication between the host is not possible when we use Docker. This is overcome by using Kubernetes, which will be in the form of cluster management. So everything will be overcome by using Kubernetes. These demerits which we have seen in Docker. First is it is not an enterprise standard because it is following imperative approach, and everything it will be giving in a command line form. Second one is if there is increase in the load, there is no auto scaling. Like suppose the C1 C container is been mistakenly deleted by someone, and it is not auto healed. Even like there is a load for that particular container, it is not scale up by itself. Everything will be taken care in Kubernetes. So let's come to Kubernetes now. So what Kubernetes tells, you are giving the specification of container in Docker commands in the CLI, but now you can give this same specification in the YAML manifest. So everything in Kubernetes, like creating pod, creating a replica set, deployment, so everything it will be in a YAML manifest. That is, there is will be a YAML file where all the specification need to be mentioned, and this is called declarative approach. And this will help in collaborating between the teams. So when you have a code at one place, like you will be having all the specification in one YAML file, so someone can come and modify that and deploy or upgrade that code. But whereas in Docker this is not happening. So now Kubernetes tells like we will do all these things with the help of one of the smallest functional unit called pod. Okay, so what is pod now? Pod is just a wrapper over the container. To explain more, in the pictorial diagram, if you see, C is a container which is running the main applications. Okay, and this container can run in Kubernetes in pod. You can see here pod, and it has the container in it. Suppose this application process, main application process, if it is having some initial config files, that time what is happening in legacy part of the containerizing concept, like in Docker and all, there is a container called C1 which is an application process, and which requires some in some of the applications it requires some config files to be kept before starting this container. So they will come up with another separate process called as helper container. When these helper container and the application container launchers, they will be launched in two different hosts. If one container is deleted somehow, or if there is some network issues and we are not able to reach that container, so both the applications will be not up. Either for this application, both the application should be talking to each other. The helper container and the application container C1, they need to talk to each other all the time. But with the help of Docker, that is not happening, because it is treating it as a separate two processes or separate two containers. So in Kubernetes, what it tells, okay, there is a pod and these two containers C1 and H1, that can come together, tightly coupled. They can come together. If they are deleted also, they will be bringing up a new pod, and this will be treated as if it is a single container. That behavior is possible by using a pod. That's the reason in Kubernetes this demerit is eliminated. Okay, so everything is fine now. Container, they had some delimits, and that has been overcome by using a pod in Kubernetes. So then why there is a deployment concept and replica set concept in Kubernetes? Deployment in real projects, we never create pod. Everything will be done using deployment. What deployment is there in Kubernetes is, we discussed earlier, like there is a delimitation in Docker of auto scaling the application and auto healing. So these two implementations in Kubernetes is done by using the deployment. Deployment, it will be like, no, it is a kind of uh, wrapper to the replica set. Replica set is nothing but it will give the number of pods which should be always running in the Kubernetes cluster. Replica set is just a controller whose behavior is such that it should maintain the desired number of pods in the Kubernetes environment. We will discuss all this topic practically now. So let me log into online Kubernetes, play with Kubernetes. Then let me start the session. We are in. Let me launch the Kubernetes cluster node 1, and let me bring up the cluster by running the commands kubeadm. Yeah, it will take a while. Every time I use this, because this is easy to use, and whenever, like, no, for practice purpose, this is the good approach. No need to install in locally. It takes few seconds just to bring up the master node and the worker node. Yeah, it's running. Meanwhile, I can bring up the worker node 2 as well. Yeah, this we can use as a worker node. Okay, it's done, and we have to add the node 2 to our cluster by running this command, join command, and then we have to execute this command in node 2 server. Shift insert. Okay, node 2 has been added, and then scroll up and run. We have to initiate the cluster networking. So we have to run this command. Enter. It will create some resources which is required for the cluster to be started. Perfect. We are good with the cluster setup now. kubectl get pods. There will not be any pods. kubectl get deploy. There is no deployments as of now. kubectl get SVC, it will be having one default service, that is the cluster IP service, up and running. Now first we will create the pod, and to create a pod we can get it from online. Kubernetes pod example. No need to remember the syntax of these codes and all. Everything we will get it from the official docs, and we have to just tweak according to our requirement. I'm just copying this pod and create a pod file here, YAML file, pod.yml, and paste the code, shift insert. Then to create a pod, command is kubectl apply -f followed by name of the YAML file, pod yml. Pod is created, perfect. So run the command kubectl get pods. Okay, there is a typo, it's get pods. Yeah, Nginx pod is up and running now. So as I told earlier, why there is a concept of deployment in Kubernetes. This pod is created now, but suppose if this pod is deleted by someone, delete pod and followed by the pod name Nginx. Okay, so now this pod will not be coming up now. Let me create a pod again. Using that same pod YAML file, it's created. Let's run same command now. Get pods. It's up and running. To see the IP address of the pod, you can give -o followed by wide. You can see the IP address of the pod. Now let me see if that is up and running. Curl 10.5.1.6. Yes, we can see the Nginx page. So if the customer is using this web page and suddenly there is a this pod is went down, like someone have deleted it by mistake by running this command delete pod, or like no, somehow this pod got down, so delete pod. Now when we run this curl command, it will not be reachable because the pod is not present. To overcome this, the deployment concept in Kubernetes comes to the picture. What deployment tells, let me go to the let me pick the example for deployment. Kubernetes deployment example. I'm taking all the code from the official Kubernetes doc itself, and let me take this and then run. Create a YAML file called deployment.yml and paste the code. Come out of it. So let me show you from here. So it is having kind type is deployment, and for pod the kind type is pod. Okay, and the name of the deployment is Nginx deployment, and here it tells replicas. The number of replicas is 3. It means all the time there should be 3 pods up and running. So this will implement the auto healing feature of Kubernetes. Suppose by mistake if out of 3 we have deleted one of the pod, so the other pod will come up by itself. No need to have any manual interventions. So one of the demerit for Docker has been met using replica set, that is auto healing. And here we can give all the specifications for the container. No need to mug up this syntax and all. Everything we can get it from the official docs itself. That's what I am doing from here. And like if you see here, this is the container port which is getting exposed for the Nginx applications. So let me deploy this. For deploying, it's the same command kubectl apply -f deployment.yml. Okay, perfect. So as you've seen in the code, it should bring up 3 more pods because the replicas count is 3. kubectl get pods. Yes. So 3 pods are up and running. And as I mentioned, deployment is doing this auto healing concept by using a controller called replica set controller, which is the controller of the Kubernetes. So it will be creating one replica set. So for the replica set command is rs kubectl get rs. This is the replica set command. You can see here the desired count is 3 and the current count is 3. All are ready. And let me see deployment. Get deploy. We will be having nginx deployment up and running, which is having 3 pods, and all the 3 pods are available. Now I will be deleting one of the pod. kubectl get delete pod, and let me take one of this pod. Delete. So auto healing concept, it should bring up the one more pod. As one pod is destroyed, so it should bring one more pod. So you can see here one more pod is up 11 seconds ago. So this is the concept why deployment is being implemented in Kubernetes. That is because to implement the auto healing concept. Okay, auto healing feature has been implemented in Kubernetes. What about auto scaling? Suppose we have like if we are running any e-commerce site or anything on particular seasons or some festival occasions and all, there will be a more traffic. So in that case, like we want to have more number of pods to be up and running. So in that case, we can just go to the YAML file. Let me open that YAML file, deployment YAML file, and then we can increase the count of replicas. So let me make it as 6 and then save. Then run the command kubectl apply -f deployment. Let's see, there are 6 pods should be up and running. Get pods. Perfect. Yeah. So this is fulfilled the auto scaling features in Kubernetes. Hope these concepts are clear. If you have any doubt in any of the timestamp like that, yeah, you can just comment over this video so that I can come back and I can work on those queries and reply to your comments. Thanks for watching.